Alright, let's see if I'm streaming or not this time. I think it wasn't working. Let's see if this works. Sure. Ruh-roh. What's going on? Okay. Ooh, I am live. Am I live? What's going on? Okay, my screen is black. That's not good. Let's move that up. There we go. Okay, I'm live. I think I was live back then, but it was a bit goofy. Anyways, we're writing our own malloc. Will probably be multiple parts, but you know, at Mason. So we'll be using Mason to build my alloc because that'll be fun. This page shows the ground on how to create a Mason build. Let's start a basic program. Let's move. I'm in my experiment branch. Oh, I get branch. Get branch. No, get checkout. Mason setup. Wait, dar source. I have source. Move main.c into source. Alright. Oh yeah, should probably do that. cd source and then main.c. Open another one. cd my ow. Let's go here. Let's not do that. Printf. Hello Mason. Okay. Huh. Right. Let me check how other softwares, how other implementations do it. Where is it? That's mason.build. Okay, so mason.build project my alloc. Do I have my alloc with an underscore? Let's see. Repos. My alloc. Let's put an underscore. My alloc C. Executable. Out. My alloc. Run. Main.c. Or is it let's see. What is the executable? Source / main.c. That's right. And then setup builder. Oh, what? Okay. %s. Why is it only replacing the first instance? I thought that was global. Vim globally replace all. /G for all. Oh, what? Okay. Mason builder. List. Nice. CD builder ninja. Mason compile. Not a Mason build directory. What is going on? Oh, CD builder Mason compile /my_alloc run. There we go. How nice of them. I won't be needing that. Let's go to source. Don't need that anymore. Let's see. Get status. Get commit -m. Set up Mason. Check out. Alright, there we go. See if that's set up. Nice. Alright. Get branch -d, right? Or Mason setup. Get branch. Clear get merge main experiments. Check out experiments ls. Huh. Interesting. arm a.out os. Make dir source. cd source. So we find the starting address of heap memory, right? Nvim main.c include standard io.h main. What? You don't auto indent? What's wrong with you? There you go. RC char rv. So we're ending address of heap memory. Oh. So S break 0 is the end address of heap memory. Tree data structure where each node is greater or equals to. What is the tree data structure? Let's see. So it's hierarchical to organize data that you can navigate. Parent node, child node, that's a tree, okay. Siblings, leaf nodes. Parent node, yep. Child node, yep. Root node, top node, yep. Yeah, fair enough. Leaf node. They don't have any child nodes, so they're on the bottom. Yep, fair enough. Ancestor of a node. Any predecessor nodes on the path. A, B are the ancestors of E. A, B. Oh, okay, fair enough. But B is also the parent, so you can have a parent and an ancestor. Descendant, yep. Sibling, yep. Level of node. Okay, root node 0, yeah, okay. How is the heap a tree data structure? Why would you have the heap be a tree? A complete binary tree that satisfies the heap problem. For every node, the value of its children is greater than or equals to its own value. Okay. Heaps are made for priority queues where the smallest is on the bottom. No, the smallest on the root. Oh, okay. Whew. Max heap is where the highest at the top, min heap is where the highest at the bottom. Right. How to get beginning of heap in C. Yeah, but I don't want to go through the links one. Let's see that later. Stack. Didn't I read this? Huh. So S break is where you have heap memory. So it's like this is your heap and it breaks on this point, say. When you do S break 0, it returns that address. With an S break of 8, it goes up 8 and then it adds that address. Okay. Well, if I want a free memory, oh, I do know the pointer to that. Okay, that makes sense. So if I want to allocate something, if I want to allocate 8 bytes, I have int my point equals S break 8, return 0. What's S break? Man, S break. Change locale, program break. Break sets the end of the data segment. And success, yeah, S break returns the previous program break. And the break has increased. Initialization of int pointer from int. What does sbreak return again? Sbreak returns the previous program break. When the break was increased, this value is a pointer to the start of the newly allocated memory. An error, negative on the set. Huh. Fair enough. See what happens first. My point. Call to declare function. Do not support implicit function. What? It's in standard library, no? libc. Oh, it's you. Okay. Unist. Right. Let's see. 6115109, 6115109, E9000. Why are they the same? It returns the previous break, right? So oh, so maybe it's to do that instead. Set. Right. Yeah, there we go. Now we allocate 8 bytes. So we first allocate 8 bytes, and when that happens, let's draw this out. So let's say we have a stack. We have a current break here. No, that's not a stack, that's a heap. Silly. We call my point. So we go up by 8, and it returns the previous break. So it returns that. So that's my point. And then when I call sbreak 0, I then call the new. Right? No, yeah. So prev point actually stores. Okay. So then this will be prev break, and then this will be cur break, and then slash my point cur break. Oh. C main dot c dot slash a. Nice. So then that means we can now use that. Let's say prev break equals 10, and then printf %d slash n comma prev break, and then gotta free it later on, but there we go. That's nice. So we go up by that, we then store 10. Makes sense. What happens when we want to free it? Wait. So malloc is fine, cause. So what's so difficult about it, right? So I'll have like void malloc int size int pre-break equals sbreak size int curve break equals sbreak. I don't need that. Right, so gives the previous gives a pointer to the beginning of the gives a pointer to the to this thing. What's it called? To the previous heap break. The beginning of the previous heap break. And then probably we want void, right? On a void pointer. Return pre-break. So now we can do int my heap value equals my alloc 8, and then my heap value equals 24, my heap value. Nice. And then what if we just do size of int? Nice. Too much words. We have allocated memories starting at %p. Oh. I feel like this should be harder. Right? Like int new heap value equals int times 8. For int I equals 0, I less than 8, I plus plus. New heap value I equals I times I. So that'll be, yep. And then let's do this. Printf set d new heap value I gcc main. So that's 1, 2, 3, 4, 5, 6, 7, 8. What? Maybe free is like hard to like incorporate. Right? Like there's no way it's this easy. Okay. Oh. Oh yeah. Okay. Yeah. Never mind. So void my free void pointer void. Void p. Map physical memory to virtual addresses. God, I hate sites that, like, when you highlight, they show you these, like, little things. Like, no, I just want to read the article. And there's a syscall that lets us allocate memory of a size. Map physical memory to virtual addresses. Okay. Syscalls are time consuming. What's probably. Huh. So we would need like a global heap base. Huh. So how do we access the heap metadata? Pthread mutex lock. tail. What is pthread mutex lock? malloc.h. What are the headers? Okay, so we get a kernel call, let's go to load. But you can also use sbreak. How does valgrind work? What is that question? What does that even mean? This address is outside your program heap area. It's heap fragmentation and problems to the extent it can make the heap take up more space. How do I access my own heap instead of breaking sbreak? Manipulate your processes page table. Yeah, your CPU translate virtual address to physical one. You can access the mapped memory for the first time. Page fault. The OS kernel can jump in, fix it. Oh, so the kernel does it for you. But what if I want to do everything myself? Oh, well, no. I'll figure it out later. I'll read that book later. What is that? Oh, that's my other stuff. So how do I access my own program heap in C? Hmm. Um, huh. Okay, let's figure this out. I've kind of got an idea in my head. So let's say we have a heap. We're drawing it horizontally because why not? So let's say we have a heap here, right? We have a global start. We have a global heap start. Right. So every time I call free, I go through heap start and wait, that's kind of cool. So I go to the heap start and I initialize a block, right? And that block will always be metadata, which will then contain a pointer to the next heap block, right? And then that, so like let's say it's that, right? So then that means, let's change the color. That means that that will point to that address. Say it's that, right? It will also drop the size of the heap, and it's if it's freed or not, right? So it's like a linked list. That's a classic 1511 reference. Anyways, so how do I make a global variable and have it persist? It's like extern or something, right? What the fuck's going on? I forgot how to code. Ay ay ay. Type def struct. What the freak? Okay. Bro. Space notification dismiss. Type def struct block metadata. And that will include bool in use, int size, metadata. Next. And then what? Wait, but if I use a block, let's say I've got this array here, right? Let's say this will be metadata. Very cool. And then so if I have the block of metadata and it has a pointer to the next block in memory. So let's say it's that. What's gonna happen is that, oh, so then that points to the beginning of the next block, which is metadata. But we also need to specify the end of metadata, and we return that, right? So we actually return that to the user, and they can use that. The metadata is abstracted, and every time we search through the heap, we start off on this block. Yeah, alright. So, we should probably do something like if not def, malloc h, define malloc h, and if include standard bool .h. Type def requires a name. Is that not it? Struct name. So we need to tell if it's in use first. We gotta figure out the size. The next block of metadata, and then block metadata end. Metadata end. Right. Nah, this is too complicated. I'll figure type depths out later. Nah, it's fine. S break returns. S break returns that, right? S break returns that very block. Next time you call 8, S break returns that as well. Do I even need S break? Because if I'm doing keep allocation by myself and I'm doing blocks, I don't think I need it. Like I don't need to set the breakpoint. You have to make sure no memory has been allocated yet. The best way to do this is to assign the return value at the very beginning of main. Well, that's a bit hacky. I gotta initialize the beginning of the heap in main. That is a good point. You can just use an arbitrary address and not have the beginning of heap. So you can do like a hack where it's like int temp. And an address of temp. Wait, can I not just use Oh, am I cooked? Let's go in here. malloc.c, multiple definitions of malloc. Oh yeah. Okay, yeah, fair enough. Let's call malloc 8 int my int. Int. Oh wait, I should turn that into pointer and delete that. My int equals 42. Printf. Stored in %p /n my int. Let's do freeze later. Expected identifier. What? Why would I do that? It's a struct. Hmm? What? Okay. Oh, it's a comma. I need a pointer. To the end of this block. Equals address of start meta. I feel like that's illegal. It's not. It is. Is it? Oh, it's not. Uh, 580 E6 AECF 260. Oh, okay. Wait, wouldn't that seg fault? Uh-oh. Because I'm doing all of this on the stack. None of this is on the heap. I'm writing my own heap, but it's on the stack. Ah. How is this guy doing then? Malloc. Gotta start malloc. This is hurting my brain. Well, not really. It works. But it should be storing it on the heap, not the stack. That's annoying. Alright, maybe I get some food first before working on this.